The diagram shows the structure of 5 hydrocarbons. So we got 5 hydrocarbons, 1, 2, 3, 4, and 5, which 3 hydrocarbons are isomers of each other. Now, hydrocarbons, first technical term, and the second is isomers. Let's first understand what is a hydrocarbon. So hydrocarbon is a molecule which is made up of hydrogen and carbon atoms, right? That's why we call them hydrocarbons, like hydro and carbons, hydrocarbons, right? Similarly, isomers, right? Okay, so isomers are those molecules which are having same molecular formula or same chemical formula. Let's say same chemical formula, but different structure. Okay, they will be having different molecular structure, but they will be having the same chemical formula. Now we need to figure out which 3 of these 5 hydrocarbons are actually the isomers of each other. So we can say that if I'm going to count it, so this is 1, 2, 3, 4, 5. So this is C5H. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 12. C5H12. Now let's talk about this. So this is 1, 2, 3, 4, 5. So C5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is H12. This is also C5H12. And see this 1, 2, 3, 4. These are 4 carbons. So C4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. H10. We got the 4th hydrocarbon, which is 1, 2, 3, 4, 5. So this is C5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is also H12. And lastly, we got another hydrocarbon, which is C4, because 1, 2, 3, 4. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. H10, right? So clearly, hydrocarbon 1, hydrocarbon 2, and hydrocarbon 4, all of these 1, 2, and 4 are having same chemical formula, C5H12, C5H12, and C5H12, but their structures are different, right? So they are isomers of each other. So we can go with option A, which is suggesting that 1, 2, and 4 are the isomers of each other.